So, welcome. This is Adrian Kosmaczewski.
Yes.
Yeah, got the name right. From a company called Vision.
Yes.
It's not VSHN, Vision like in...
Like in Vision.
Okay. And I have asked him to join me here because we have been working with Vision for quite a while on container technology. So they have helped us building the container. Oh, there's a clicker, even better. They have helped us build the container infrastructure on top of SWITCHengines. Vision is a certified Kubernetes partner and doing all kinds of really great stuff. Our history goes back almost to 2014. When we were hiring a guy, or in a hiring process, we interviewed a guy called Tobias Brunner, which was fabulous, and we wanted to hire him in, but our HR department took too long, so Vision hired him instead. We are still friends, and we work together. So this talk. We'll try to make it short to not keep you waiting. SWITCHengines, as you know, is the computing and storage platform for universities. I'm not going to go into all details. It's an OpenStack-based environment like our colleagues at Psi are building. We've been in production for a couple of years. We are growing. It's all Swiss-made, Switch-made, Swiss, whatever. But we want to get technical, and we want to answer maybe some of the questions that came up in the last instructor's presentation, just show you how we can actually put metal to the road, rubber to the road, GPUs to containers, because that's something we see as a demand. And maybe it's a bit presumptuous of us to be here, because we're not HPC at all. Right? If every time I talk to Mikhail and say we have bought a couple of GPUs, he laughs at me because it's 10, 12, 20, and not thousands of them. So we're not an HPC facility as such. We see ourselves as a general purpose cloud platform. However, there has been demand for GPU power from our customers, and usually not from the guys like you, from the people like you, from scientists, but for smaller things, master students. We had one master student that made a project on machine learning with yodeling. He used a couple of our GPUs. So that's maybe where we come from. We provide for the smaller niche market. Another thing that might be of interest to you, maybe, however, is something we're starting up, that is the long-term storage project. I know that there is a lot of data. We learned how much data sliced a mouse brain takes today. So 0.5 terabyte times 3 brains a week gives 1.5 terabyte. Do that a couple of years and you end up with data. You want to store that. You want to store that cheaply. That's something we're spinning up now. If you have research data that needs to be available, stored offsite maybe, not on your premises, if there need to be certain regulatory rules, we are providing that. Speak to Anne, my colleague in the background, if you have any interest in that. So, GPUs and introduction. Right. I'll give you that instead. I don't know if anybody can read Greek. It's all Greek to me. You may know the word carrying owls to Athens. Something Aristophanes said 400 BC in a satirical comedy. I'm not going to explain GPUs to you because you all know much more about that than I do or we do. But we are going to briefly go through the stack of setting up GPUs in an OpenStack environment. Maybe it's something you can learn from. This is a bit technical part. I'm going to skip. I'm not going to read all the things. There are a couple of things you need to be aware of. You need to enable IOMMU on your hosts. So do that. It's very easy to enable GPUs. You need to figure out what you have installed. You can ask things. You get these little numbers here, 1EB8, something you need to take care of and you need to remember. Every GPU has one of these device identifiers. You need to tell Nova, the compute engine or compute orchestrator of OpenStack, that you have GPUs. So you need to enable a couple of settings in the Nova configuration files. You need to tell them that you have that you want to pass through any PCI devices that come from a specific vendor. So the vendor 10DE is NVIDIA. They have a bunch of different cards. That's where this number comes from that we saw before. If you do that, you define aliases. So you have a bunch of NVIDIA cards here, P100s, Titans, T4s, and you can add them to, you can reference them later on. Then you need, OpenStack has a scheduling mechanism. When you schedule a virtual machine, it will try to find a host that satisfies certain conditions. This is done through scheduler default filters, and there's a bunch of them. You add one more, the PCI pass-through filter, which will look for hosts that have certain PCI capabilities. And then basically what you need to do is you need to define new flavors in OpenStack, so definitions of virtual machines. You give them some cores, some RAM, and you set one property, the PCI pass-through property. You use the alias you used before. You also tell the flavor how many of these GPUs they should use, so 1 GPU or 2 GPUs or 4 or 8, whatever you have in your hardware. And if you have TitanX GPUs, which you shouldn't, because NVIDIA doesn't want you to have cheap hardware, they want you to use the real one, you need to be careful. NVIDIA also doesn't want you to run virtualized loads on these GPUs, because they're for gamers, they're not for scientists. So you need to fake the virtualization layer that it will not snitch that it's running on KVM or on a virtualizer.
Can we publish your video? No.
Of course you can. Of course you can. So you need to add 2 patches to OpenStack that will give you more capabilities, the hide hypervisor ID and the hide hypervisor in the images and flavors. And then you basically just say, if you have a flavor like that, hide the hypervisor ID equals true, and a virtual machine that comes up with that property set will pretend that it's running on bare metal, and the NVIDIA drivers will be happy about running in that virtual machine. What can I say? They're difficult to get, though, because they're used for Bitcoin mining, I guess, or Ethereum mining. So, but they're much, much, much cheaper than the P100s or V100s or whatever.
Not that much cheaper.
Okay. So, anyway, that's it. It takes a couple of minutes to set up, and then you're up and running. When you ask or inside one of these virtual machines, you get the power. Problem solved, right? That's basically all there is to it. And then you can do whatever you want to do, and that's probably where the part where you guys start to work with adding specialized capabilities, Slurm, whatnot. This is not something that we are concerned with. We just give you the infrastructure. Right. So that covers the virtual machine part, but then there's the whole container part, and this is where Adrian comes in. OpenShift is a... Why don't you tell us what OpenShift is?
What is OpenShift? That exactly. So, hi everyone. So, how many of you have already worked with OpenShift? Okay, I had only one hand, so it's really nice because I have a small demo to show you. So basically, OpenShift, it's an infrastructure, a PaaS installable infrastructure that you can install in your own cloud that builds on top of Kubernetes. Since version 3, it is built on top of Kubernetes. It used to use its own orchestrator in versions 1 and 2. And it's an open source system, Kubernetes, and OpenShift as well. It's built on top of it. So I'm going to, first of all, show you what OpenShift looks like. And it should be something like this. Very good. So what you see on the screen right now, it's basically a local live OpenShift installation that I have in my laptop right now. It's called MiniShift. You can use it for development purposes. It's actually, or for demos, like in this case. It's actually very useful. And as you can see on the screen, and it's very hard for me to go like this, but I will try. You can create projects, and these projects can pretty much use any programming language that you can imagine. So here I have 3 projects that are already, one of them is an Elizabethan insult application, right? So I'm going to click on it, and I can see that it basically consists of 2 deployments. One deployment for a web application built on top of Java, and another deployment with a Postgre database, very simple. And inside of a deployment, you've got pods. And the pods are exactly the Kubernetes pods, inside of which are running at least one container that contains a Tomcat application itself being the application itself. And I can click on this small link, and I can see a very nice insult on the top, which is "thou art an infectious dog-heart barnacle," and if I want to reload it, etc., etc. So this is running inside of OpenShift, inside of a pod on a Kubernetes that itself is exposed to us for this. So I can as well explore my pod, and I can see in real time the full logs of everything that is going on inside of this thing. I can inspect it, I can see the environment. It's a very, very nice administration tool. It provides some monitoring capabilities. It also can be tied to, for example, a GitHub repository. So basically, it will automatically rebuild and redeploy a new version of the code every time that your developers are deploying a new version to one of the branches of your GitHub repository. So this is very handy because it really makes your deployments automatized. And it, as you could see, it works with pretty much every technology that you can imagine. So that was for OpenShift, but that's not all, because there's as well in OpenShift a command line tool that basically here it's outputting exactly the same information that you've seen on the screen. This is live directly from my OpenShift container. And it's showing exactly the same application with the insults application. Very good. Enough of insults. Let's go to something a bit more civilized. There we go. So we're going to talk about how we've seen so far how to expose GPUs to OpenStack. Now we're going into OpenShift. But OpenShift is built on top of Kubernetes. So we start with Kubernetes first of all. So we need, first of all, to know that right now the support of GPUs in Kubernetes is experimental. It basically is based in what it's called device plugins, and this is something that it's still in experimental stage. And it requires, of course, the installation on the host of the actual drivers, which is something that has been exposed already in OpenStack by what Jens has said. In Kubernetes, you define objects, things that have to be existing inside of your infrastructure as YAML files. In this case, I define a pod. A pod is one of those things that you've seen on the screen. And here in this particular pod, I am specifying that I need a GPU. I'm requesting a GPU on the bottom of that YAML definition. There are some limitations. You cannot, you have to specify it in a particular way, specifying the limits. And basically, the number of requests must be equal to the number of limits if you specify. And you cannot have fractions of GPUs as well. You only can have natural numbers of GPUs, whole numbers of GPUs. There are 3 types of plugins that you can use right now in Kubernetes for GPUs. There's the AMD plugin that you can install using the kubectl. kubectl is a command line tool that allows you to talk directly to a Kubernetes installation. You can install it using that command. You don't need to write it down. The slides will be available for you. There's an official NVIDIA GPU plugin provided by NVIDIA itself, which has these characteristics right here. But there's also another NVIDIA plugin that is basically the biggest problem with this one is that it requires, the official NVIDIA plugin requires that you replace the Docker runtime with something else that runs C, okay? So it requires a little bit of infrastructure. There's one provided by the Google Cloud Engine itself. It works directly with Docker, and it can be installed with the command right here that I'm asking you to remember by heart. Very good. So what about OpenShift? Well, OpenShift right now, NVIDIA and Red Hat are really working very closely to try to bring this to version 4. Version 4 will be of OpenShift will come out anytime soon, I hope. And right now it's in general availability in version 3.10. Right now, the latest version of OpenShift is 3.11, if I'm not mistaken. So it is available. It's something that you can start playing with. And how does it work? Well, first of all, you have to prepare the drivers on the host where OpenShift will be running. So you have to basically run a couple of yum install commands. And then when you create a new project and a new service account, you have to label your projects as using the GPU acceleration equal true label. This will tell OpenShift that you are requesting that you are going to use GPUs on your pods. Then you need to deploy a Daemonset. Unfortunately, I cannot do a live demo of that specifically because this particular laptop uses an Intel GPU and there are no available plugins for the moment. So it's unfortunate with this machine I cannot do a live demo, but I would have loved to do one for you. And then, of course, you need to deploy a pod that requires a GPU. And in this case, well, it's basically something that I've taken out of a live sample where you're basically doing a calculation using a GPU. How does it work? In terms of topology, basically you are assigning the GPU to a particular pod. Pods cannot share a GPU. They get assigned specifically the GPU for themselves for the duration of the work. And of course, I don't have to tell you, but there are immense gains to be done. This is something that this is from a paper published by Red Hat itself. We're basically doing calculations in the medical industry. The gains are considerable using GPUs, as well as, well, if you're into going into casinos and you're into Monte Carlo. No, I'm kidding. But you can also get a lot of performance gains by using GPUs. But I'll give back to Jens Christian for wrapping up this presentation. Thank you.
Thanks. So maybe one question that didn't get answered is why use OpenShift at all, not Kubernetes? And if you know Kubernetes, you know, and we've heard Sergio talk about it and other people, there are a couple of problems with Kubernetes. It's not multi-tenancy capable. There's root escalations and so on. OpenShift takes care of all that. It provides a service on top of Kubernetes to provide a multi-tenant secure environment for Kubernetes pods. That's also the reason why we are looking at that, because all of these slides, while they look daunting, that's really the easy part. And as a service provider, we have much more difficult problems. Is how do we make that all these capabilities available to people? So we need to give access to special flavors. As I mentioned, we create special flavors. We need to see how many GPUs do we have. We don't have thousands. We cannot just give out GPUs to everybody and just let them rip. And of high interest to us is we also need to create billing records so we can invoice you for for the cost. So in my experience as a product manager for SWITCHengines and the whole service thing, these are the really difficult problems in providing services. So it's not the technical implementation, but getting that to customers. So we've done a couple of things. We have a user interface, we call it EnginesAdmin, which we give out to our customers, to the universities, to the departments in the universities, where they can self-manage whatever resources on OpenStack they want. So create projects, assign quotas, add and remove members, and so on. We have this week we have included the capability to provide special flavor support, so we can assign GPUs, the various types of GPUs that we have in our clusters, and other special capability flavors like local SSDs and so on. And our interface takes care of assigning the relevant flavors. There are for example, 4 NVIDIA T4 flavors here. They are then assigned to the project and can be used by the users. So that's something that we have added on top of that. And it's something we will probably also work with the Vision guys to create that capability for the OpenShift cluster. So an admin of an organization, one of our customers, can assign GPU capabilities to certain OpenShift projects and not. The other is finding out what GPUs are in use actually and how many are free. Currently, this is how we do it. We ask our Nova database to tell us the status and the labels of our devices. Clearly, this is not user-friendly, not very user-friendly. It's not even admin-friendly. So we're working on adding a service that will allow admins to see what is the current state of the GPU availability in my cluster, and can I go out and assign GPUs to projects and so on. We have billing. Why use one billing system when you can have 2 billing systems? So we have one written in-house that we have updated with the capability of looking at flavors and determine if they have GPUs. We're also working with a vendor, a spin-off of ZHAW, Cyclops, that they implement that functionality for us. And as I said, we will work with Puyo and Vision to include these capabilities as well in the layer that they provide on top of OpenShift. There's layers on layers on layers on layers of software to create a service. So where is this being used? One of our main customers is the STC. We've heard about them today. There are various machine learning, deep learning projects that run partly on CSCS hardware, partly on our hardware. I talked to the people there. They are using bare metal or bare VM GPUs, and they also have deployed their own container infrastructure with Renku, and they use GPUs inside those containers. And then we have, just as an example, the Fachhochschule Nordwestschweiz, the master students with the Yodeling project is one of these, where people are giving GPUs to students for a couple of weeks or months to run whatever thesis projects they need to run. And we have various test instances. This is something that we have been testing over the last couple of months, and we're now making available to more easily to everybody. And no presentation would be complete without Frank Zappa. Of course, Frank Zappa, the master of audience participation. No Frank Zappa fans in here? Okay. One, so you know what audience participation means. It?
No.
No. Okay. Good. We'll not go into that. Switch, we see ourselves as a partner to the higher education market. So we're trying to build products and services that benefit to you. So having 40, 50 people in the room that actually are HPC, have an affinity for HPC and use GPUs and so on, we can put you on the spot and ask questions of you, and you can help us determine the future direction of our product. So the first question is there a need for GPUs in a cloud infrastructure where self-service, not HPC but on a smaller scale? Is that something you can see a need for? Ask you to raise your hands. So 2, 3, 4, 5, 6, 7. Okay. What are the usage patterns? How would you, those that have raised their hands, how would you use that? Is it something where you would use GPUs for a couple of hours, couple of days, couple of weeks, on and off, spiky, long term? Can I get some spiky? Couple of hours, couple of days, something like that? Mm-hmm. Couple of hours? Regularly? Yeah, okay.
Yeah, we have also used Switch for education purposes, for courses,
yeah. The SIB courses? Yeah. We didn't manage to give you GPUs for the last courses. We were that close to having them delivered. Exactly, yeah. That goes on the use case slide next year, right? Hopefully. Any others? On and off. So it's something you would like to be very rapidly deploy them and shut them down again without jump troops. Okay, great, thanks. How would you like them? Would you like them in VMs or would you like them in containers on OpenShift? Can I see the VM hands and the container hands? Okay. We had about 10 people that said they were interested. Now there's only 2 left, so there's. Would you?
Maybe you want them in bare metal. Raise your hands in bare metal. Because maybe you don't want virtualization whatsoever.
Exactly. Yeah. No. The question is, I showed how to deploy them on VMs. That's the VM use case. Adrian showed how we can make them available in OpenShift or Kubernetes. Which is there a clear way that you are a clear preference for one or the other delivery type? Because if you're not interested in OpenShift at all, we'll just.
I will show myself to the door.
So, I don't get a feeling back from the room. It maybe.
OpenShift. Raise your hands. OpenShift.
You can decide which one.
Kubernetes. Kubernetes.
Kubernetes survives.
Please.
For the use cases I see, I think either.
Either will work. So we have to do
Either of the 3, let's say.
Bare metal VMs or containers.
Be a multi-tenant thing, as I see it for spike usage. So Kubernetes is also fine. If it's OpenShift, that's whatever. If it's VMs, that's a bit more plumbing on that side. But it's also. I'd say probably with a container for use case, I see.
More containers.
Containers. Raise your hand. Containers.
There's another one.
There you go.
Okay. So the question is Kubernetes or OpenShift if you do containers, because you can also deploy a Kubernetes cluster on SWITCHengines and roll your own, or we can help you roll that. It's also like the SDSC guys, they run their own Kubernetes clusters on top of our infrastructure.
Maybe the fact is basically, given that it's so experimental, I mean, it's still on early stages in terms of Kubernetes OpenShift, most probably your requirements are requires more stability, which is something that you were mentioning this morning in your talk. Basically, it's maybe you need a little bit more settle down, the dust goes away, and then you're like, oh, well, okay, now it works. It's stable, we can move forward. That, I admit, it is probably a bit too early in that sense, yes.
So should we continue building this for you?
Yes.
Yes, please. Anybody say no? No, don't want to hear it. Okay. And will you be using it? Build it and they will come. Sort of that. No, yeah, exactly.
I won't sign anything.
You don't have to. You know, see your face. Good. So there are a couple of announcements. You can have them now. The cost is up there, and the OpenShift thing is in beta right now. You're free to use it. Conditions apply, and we will have that as a service in 2020. So with that, thank you very much, and we went way over time. I'm sorry.
So I suppose you asked many questions. There is still one question from your side also. If this is not the case, let's start finishing.